Today we're going to look at solving equations when we have variables on both sides of the equal sign. The extra little difficulty here is that you need to eliminate values on both sides. So let's start off with an example like this. 3x plus 2, 4x equals 4x minus 1. As it says, you need to get the variable terms alone on one side, and it doesn't matter which side. And there is a little bit of a rule though. Try to make it so that the side you move the variables to will be positive. So we're going to look at the 3x and the 4x and say, well, 4x is the bigger positive variable term. So draw the barrier, and we're going to try and get rid of the variable term on the left side by subtracting 3x. They eliminate on the left when we simplify, and we have 1x on the right now. The thing is, the 1x is not by itself. I have a minus 1 there, so I'm going to have to add 1 to both sides to get rid of that, leaving me with x equals 3. And remember to read it from the variable. You can check this by replacing it back in and making sure that the left side equals the right side. As you can see, 11 equals 11. Good. Number 2. We have variables on both sides, 8y and negative 3y. We want to get those together. So we're going to try and bring it to the side where the 8y is. So draw the barrier, and let's get rid of that negative 3y first by adding 3y to both sides. That's going to give us 11y on the left, minus 9. And on the right, we have a 2 left there. We now have to get rid of the minus 9 by adding 9 to both sides. And that gives us 11y on the left and 11 on the right. This time we have a coefficient on the y, so we need to divide by the coefficient, which is 11, both sides. Y equals 1. Good enough. And you can check it by replacing it back in. 8 minus 9 equals negative 3 plus 2. They both equal to negative 1. There's a shortcut that I'll show you some other time. Solve. We have two variables this time, both on the same side, so it's a little bit easier. You don't have to move anything across or eliminate a variable on one side. You simply put the two like terms together and then divide both sides by that coefficient 4, and you get x equals 1. Check the answer by replacing. Number 4. This one has an extra little difficulty because we have to expand the bracket. Remember, distributive property is going to multiply the negative 7 by both of the terms, negative 7x and positive 21. This time only one variable term, so it's a little bit easier. And I'm going to just subtract 21 from both sides to get the 7x by itself, the negative 7x, and then divide both sides by negative 7. X is equal to 4. Check it by replacing. Negative 7 times positive 1 equals negative 7. Special case. What's going to happen here? Well, I got 2x on both sides, and so something was weird. I don't know which side to move it to. So I'm going to take 2x away from both sides. No more variables. What happened? Well, when you have a statement like this, there's never any true value that will work for x. This is never true. So we say there's no solutions. Here's another one where we're going to have something weird happen. When we expand the bracket, we get 3x plus 3 minus 5. You'll see the 3x on both sides. And so when I subtract 3x from both sides after combining the like terms, I'm going to have negative 2 equals negative 2. This is a true statement. So what it really means is that no matter what value of x I would replace onto both sides in this equation, you're always going to get a true statement. So there is an infinite number of solutions to this. Hopefully that helps a little bit, and we'll just sort of continue on with the shortcut some other time.